Hi, I'm Conrad. I talk about TRAIL, which stands for Task Relevant Adversarial Imitation Learning. This work was done with all these folks whose names you can see on the screen. Enjoy! In reinforcement learning, we usually assume that we have access to rewards aiding our agents. However, it may be impractical or even impossible to get those granted rewards, and even if we do have them, they may be too sparse or inaccurate to be actually useful. In those cases, we may want to use imitation learning methods as they recognize and reproduce demonstrated behaviors. It means that we can make our agent act as shown in some pre-recorded demonstrations. There are a few approaches, but we'll focus on adversarial imitation. Generative adversarial imitation learning, or GAIL, is inspired by GANs. Here, a discriminator tries to assign higher values to expert trajectories and lower values to trajectories generated by the policy we would like to improve. These predictions are then converted to be rewards and input to the agents. Let me start with a very simplistic example. Here, in the beginning, it's very easy to discriminate based on the performance between expert states and agent states. However, as the agent is getting better and better, our decision boundary has to adapt. So it adapts, and finally, hopefully, there is no way to discriminate between expert states and agent states. That would mean that we've solved our task. However, in practice, it's not that simple. One reason for that is that our agent doesn't fully control input to the discriminator. And why is that problematic? Let me explain that with an example. Imagine that we collected some data with our robotic arm in the past, and then something happened to the gripper. And we had to replace the gripper with a new version which has a different color. Now, the discriminator can trivially discriminate between expert and agent based on the color of the gripper, which is beyond the agent's control. It means that the plot I showed you before is overly simplistic. And in practice, it looks more like here, where a decision boundary is based not only on behavior-based features, but also, potentially, some spurious features like color of the gripper. In the beginning, it's not a very big deal, but when the agent improves, our problem is getting more severe. Finally, spurious features may be actually more reliable as the indicator of being an agent or expert. That led us to the first takeaway message, which is spurious associations may gain rewards are informative. How can we address that? Let's imagine that we can disentangle our decision boundary into the right boundary, which focuses on the behavior only, and the wrong boundary, which exploits spurious features. If we can do that, we are good already, because we can simply make our rewards be based on the right boundary only. However, in practice, it's very hard to do this disentanglement, and instead we propose to unlearn our discriminator this wrong boundary. Details how to do it are in the paper, but the key idea is to identify gradients related to spurious features. The way we do it is by feeding our discriminator with two batches of a different nature. The first batch is like in the original GAIL, but the second one is built with different data for which we know that the performance is not discriminative at all. Hence, gradients obtained for the second batch have to relate to spurious features, because only by using them one can discriminate between expert and agent. Once we have these gradients, we can make our discriminator be blind to spurious features. Hence, the second takeaway message is TRAIL prevents the formation of spurious associations. Let me share our results for 4 robotic manipulation tasks. TRAIL, these red curves, outperforms our baselines and achieves expert level on all tasks. TRAIL is better than D4PG from demonstrations, even though this baseline uses both demonstrations and grand jury rewards. It means that these grand jury rewards are too sparse to solve harder tasks. This is resolved when we use GAIL-based rewards, which are dense and tend to aid exploration. Here we have some qualitative comparison. GAIL agents are able to solve only one task, the easiest, while TRAIL agents nail all of them. On this slide, I have both takeaways. Let me reiterate through them. First, spurious associations may gain rewards are informative, and second, TRAIL prevents the formation of spurious associations. Thank you very much for your attention. If you have any questions, let us know or simply check out our paper.